Hey guys, I'm Pat Kelly. In this problem, they give us these two matrices A and B that I have here, and then there's a part ABC to the problem. We're supposed to find, if possible, each of these products, okay? So, let's see, for my first one. Of course, what we're really practicing here is matrix multiplication, so I'll definitely talk you through that process. But I'll tell you, your first step here really should always be to write those matrices, right? Rewrite them. I've got them staring at me, but you want to get them nice and tight and lined up with each other in order to do that multiplication pattern correctly. So A times B, I'm just going to rewrite these matrices right next to each other. There's my A, and then my B. B matrix up here, 2, minus 1, minus 1, 8. And the reason I'm stressing that, even as a first step to get started, is now that they're nice and tight and lined up with each other, your multiplication pattern is when you're going over and down, over and down, over and down, over and down. And I'm going to do that now for this one. So you'll see it in action for these two matrices. But my first thought is, I know the directions even said, do this if possible. Is it possible to do this A times B in this case? You're always answering that by your dimensions of each matrix. This one is 2 by 2. This one's also 2 by 2. And those two middle numbers need to match. Let me even do that in a different color if you want. This one's 2 by 2. This one's also 2 by 2. This is what I mean by the two middle numbers. If those guys match, you can do the multiplication. All right. I also want to point that out then because your outer numbers tell you the size of your answer. So I know my answer is going to be 2 by 2. So as I'm getting ready to get my individual entries of this matrix, I know I'm only going to need 2 rows. I only need 2 columns. My columns are going to be kind of wide though because I want to show you the over and down pattern. Let's get to it. So in order to get that first entry, I multiply 1 times 2. So 1 times 2 is 2. But then you add over with this finger, down with this finger. So 2 times negative 1. That's a negative 2. I'm adding negative 2. Okay? Again, 1 times 2, subtract. I'm going to go over, down, and multiply again. Okay. Now I'm going to move over to my next entry. I'm still in that first row, second column. So I grab the first row here, but the second column here, and do your over and down pattern. 1 times negative 1 is negative 1. Over with this finger, down with this finger, and 2 times 8 is 16, so I add 16. All right? Even in this problem, we'll practice that quite a bit, so it takes a little bit of getting used to. Now let me go down to my second row, but first column. So I'm going to go to the second row of this matrix and the first column of this matrix and do my over and down. So 4 times 2 is 8. Over, down. I get a negative 2 when I multiply. I'm adding that, so I'll just write that as subtract 2. Second row, second column. I'll use this second row from the first matrix, second column from the second matrix. 4 times negative 1 is minus 4. 2 times 8 is 16. It looks positive, and I'm adding it. So plus 16. That's the hard part. Now you do the arithmetic. Let's clean this up and get an answer. 2 minus 2 is 0. This looks like a 15. This looks like a 6. And that looks like a 12. That's my answer for the first one. All right, let's do the second one. B times A. This is back to, I told you as a first step, write those matrices, rewrite those matrices, get them all snuggled up next to each other. And what's important here is you're writing them in order too. You're writing them in order. So B first. I just rewrote that. Snuggle that up with A, which I'm writing second, and that was my matrix 1, 2, 4, 2. Okay. Now I'm nice and tight so I can try to do my over and downs. And can I do this one? Yes, 2 by 2 times a 2 by 2. It's going to work, and it's also going to end up being a 2 by 2. So I'm going to anticipate 2 rows, 2 columns. To get those entries let me first, 2 times 1 is 2. And then over with my left finger, down with my right finger, -1 times 4 is -4. And I'm adding that, so I'll write it as subtraction. Okay, to move over in my first row, second column, I'll use this first row, but this second column. 2 times 2 is 4. Over, down. -1 times 2 is -2. I'm adding that. I'll write it as subtraction. Okay, down to my second row. I use the second row here, but the first column in the second matrix. -1 times 1 is -1. Over, down. 8 times 4 is 32, and I'm adding that. Now moving to my second row, second column. So second row, second column. -1 times 2 is -2. Over, down. There's 16, and I'm adding that. And I'm done, other than the arithmetic, so let's clean that up. This looks like it will be -2. 4 minus 2 is 2. 31 and 14. And I got my answer for the second part. Third part, be careful. The third part is a squared. And what I want you to be careful of is think back to algebra. Think back to algebra 1. What does the exponent of 2, the square, what does it mean? It means a times a. So you need to see that with your matrices as matrix A times matrix A. So I'm going to do my rewrite again, do like my little snuggling again, get them written next to each other. So there's my matrix A. And because of the thought of what the exponent means, that's my first A. You also need to write the second A. So you're just writing A again. And now you're ready for your over and downs. So this equals, I'm going to pick up the pace this time and do some arithmetic in my head. 1 times 1 plus 8. So that looks like a 9. I go over first row, second column, 2 plus 4. Let's do that again. 2 plus 4 looks like a 6. Down here, I'm looking at a 4 plus 8 is 12. And then 8 plus 4 looks like 12. Okay? And that should be my answer for that one. Okay? Practice, practice, practice.